A quadrilateral is a four-sided polygon that have angles that add up to 360 degrees. And there's two main types of quadrilaterals, trapezoids and parallelograms. So we're going to learn about quadrilaterals in general. We're going to learn about two special types, and we're also going to learn some about notation today. So let's look at trapezoids as our first main type of quadrilaterals. So, since a trapezoid is a quadrilateral, it has four sides. So, let's look at some examples of trapezoids. Here we see three different trapezoids. They have these little arrows on them, and that notation is letting you know that those sides are parallel to each other. So, trapezoids have one pair of parallel sides. So we can see here that side AC is parallel to side BD. And parallel means those sides, if we were to extend them forever, would never intersect with each other. Let's look at the next trapezoid, and we can see that side AC is parallel to side BD. And if we look at the last trapezoid, side AC is parallel to side BD. And the little arrows are just symbols to denote the sides that are parallel to each other. The highlight is just to help you follow, but we don't really leave the highlight there. So trapezoids are a special type of quadrilateral, which is just a four-sided polygon, that have one pair of parallel sides, or two sides parallel to each other. But it's just one pair. We call that one pair in geometry. So now we have parallelograms, the other special type of quadrilaterals. Parallelograms have two pairs of parallel sides. So let's look at our picture down here. And you will see that side AC has an arrow and side BD has an arrow. And that lets you know those two sides are parallel to each other. You can also see this with the notation. And let's just add a little line here and a little line here so that our notation is correct. So this notation is actually read, line segment AC or side AC is parallel to line segment BD. Okay, line segment AC is parallel to line segment BD. So this symbol right here means parallel. Okay, so that's another type of notation. Now, if we look back at our figure, where I highlighted, you'll see that there are arrows to show or denote the parallel sides. So you can see that there's one arrow here and one arrow here, which lets you know that AC is parallel to BD. Now, we'll also note that line segment AB is parallel to line segment CD. And if you look at line segment AB, you'll see two arrows, and CD has two arrows. That lets you know those two sides are parallel to each other, but they're not parallel to AC and BD because they have a different number of arrows. All right, there's some other information that we know about parallelograms. These are the definition of parallelograms. So, the opposite sides are also congruent. And you can see this again looking at the diagram. So the black tick marks show you what sides are congruent to each other. So if I look down here, I have two black tick marks for line segment AC and two black tick marks for line segment BD, which lets me know that those two are congruent, which means they have the same measure. Okay? Then if you look at AB and CD, how many tick marks did those two sides have? They just have one, right? And that lets us know that line segment AB is congruent to line segment CD. Those two sides are the same length, in other words. And that lets us know that they are equal to each other, but they are not equal to AC and BD because they have a different number of line segments. So something else that we're going to notice here is something about the angles. So notice that in the definition, opposite angles are congruent. So we'll notice that angle A is congruent to angle D. That's what we mean by opposite angles. And you can see it in the picture that angle A has one arc, that's called an arc, and angle D has one arc. We will also notice that angle B has two arcs and angle C has two arcs. So that lets us know that angle A and angle D are congruent and angle B and angle C are congruent. So in this diagram, angle B and angle C are opposite angles and they are congruent to each other. Angle A and angle D are opposite angles and they are congruent to each other. So I can write this the following way. Angle A is congruent to angle D. Angle B is congruent to angle C. That's how you write that two angles have the same measure. So that's an angle symbol and a capital letter for the angle, and then a congruency symbol, which is an equals with a little squiggly over it, and then an angle symbol, and then a capital letter for the other angle. Now, to show that the sides are congruent to each other, we would use the following notation. Side AC is congruent to side BD. And then side AB is congruent to side CD. And this is how we would denote all the information about a parallelogram. What I want you to focus on is how to draw it in a picture. So let's move on to the next definitions. So we've learned that there are two special types of quadrilaterals, trapezoids and parallelograms. Well, next we're going to learn that there is one special type of trapezoid, and there are three special types of parallelograms. And we're going to learn all the details about these next figures like we did with trapezoids and parallelograms. So next, let's go to our special type of trapezoid. So our special type of trapezoid is called an isosceles trapezoid, and I'm going to give you a way to remember this. So think about an isosceles triangle. What do you know? You know that we have two sides that are congruent and two angles that are congruent. Well, if you take an isosceles triangle and you cut off the top, or think of it as chopping off the head there. We're going to chop off the head of the isosceles triangle. That is going to give us an isosceles trapezoid. And that's what you see here. Now, we already know, based on an isosceles triangle, the angle that we have two sides congruent. And those two sides that are congruent are referred to as legs, both in the triangle and in the trapezoid. Well, in the isosceles trapezoid, the legs are also congruent. We also know that since this is a trapezoid, the opposites, two of the sides are going to be parallel. So that's what these two arrows mean. Now, let's look at the angles. We know that the angles opposite the congruent sides are congruent to each other. So we know that this angle is congruent to that angle. So that's all the same stuff we know about an isosceles triangle. But since we cut the head off, we now have a straight line at the top, which turns us into a trapezoid, and these two angles are congruent to each other. Okay? So let's look at that in a nice, pretty picture. So I'm going to put the line segment symbol here and here since it's not written in. So this is read AC, or line segment AC, is parallel to line segment BD. So we can see the arrow showing that line segment AC is parallel to line segment BD. We can see the tick marks showing that the legs are congruent. We can see the two arcs showing that the bottom angles are congruent, and the one arcs showing that the top angles are congruent. And I say bottom and top, but keep in mind that this figure can be flipped around, right? So those angles won't always look like they're on the bottom and top. So you need to know all of these attributes. You need to know it has two congruent sides that are called the legs, that the angles opposite those sides are congruent, and in addition, the other two angles are congruent, okay? So that's our special type of trapezoid. And we have 3 special types of parallelograms. So let's look at these. The first is called a rhombus. A rhombus has all the characteristics of a parallelogram, and in addition, all the sides are congruent. So that's what makes it a special type of parallelogram. So you can see in the diagram that we have opposite sides, or opposite angles, excuse me, are congruent. So this purple angle and that purple angle are congruent. These blue angles are congruent. And the 1 tick mark on every side shows us that all 4 sides have the same measurement. We also know that opposite sides are parallel, so we can put our arrows in. So a rhombus is just like a parallelogram, only all the sides are congruent. And the way I think about it myself is I think about it as a parallelogram that has been shrunk. Well, let me draw that again. So I imagine a regular parallelogram, and the fact that all the sides are congruent makes it shrink in. And that's just a memorization technique, not a fact. All right, next one is a rectangle. You're probably very familiar with a rectangle. A rectangle has all the characteristics of a parallelogram, but in addition, all the angles are congruent. Now, since we know that a quadrilateral, all the angles add up to 360 degrees, what would be the measure of each angle in a rectangle? It would be 360 divided by 4, which is 90 degrees. Therefore, not only are all the angles congruent, but they're right angles or 90-degree angles in a rectangle. So if we look at our rectangle, we know that all the angles are congruent and they're right angles, so I put the right angle symbol in. We know that opposite sides are congruent, so I put those symbols in. We also know that opposite sides are parallel, so I'm going to put those symbols in. Next and last is a square. And I always think about it, if a rhombus and a square and a rectangle, so if a rhombus and a rectangle had a baby, they would have a square. So it is both a rhombus and a rectangle. It has all the attributes of both. So a square has all sides congruent, just like a rhombus, and it has all angles congruent, just like a rectangle, which means they're 90 degrees. So all the sides are congruent, all the angles are congruent, and they're right angles, and of course, opposite sides are going to be parallel because it's a type of parallelogram. So this is the end of the section on quadrilaterals, and you have a lot of definitions. We started here. You have a lot of definitions to learn, and you have a Quizlet to help you. So please check your video page for the Quizlet.